times, but I'm not going to forget this time because I've just hit record. Excellent. So we're going to get our programming on today, and today we're going to start with the kind of like the first ideas about programming, and we're going to talk mainly about methods and return values. We're going to talk about variables, methods, arguments, why we use them. We're going to like see how Ruby looks for things. We're going to talk about some words: variable, method, return, argument, otherwise known as parameter. We're going to use words like parse, execute, and abstraction. And so what I'd like you to do is that I'm going to break you out into groups, and we're going to take 5 minutes. I'd like you to define these words. And I'll post these words in Slack, and I'd like you to define them. As soon as I go, options. 5 minutes, cool.
I'm not sure what happened. My internet lagged out.
Okay, let me try to get you back in a room.
All right, thank you.
There you go. It should something should pop up prompting you to join a room.
Not seen anything yet.
No?
Uh-uh.
Well, just go ahead and define those terms on your own. I can't seem how to get you in a room.
All right, no worries.
All right, y'all are filtering back in. And so I hope you had some good conversations defining various words. But what we're going to do is that we're going to talk about this in a little bit greater detail. And I'm going to show you some examples as soon as I try to move my windows so the video window isn't blocked by everything. This is most irritating at the best of times. And so can you all see the text in my terminal fine? Is it big enough for everyone? I see some thumbs up. Any thumbs down? Just unmute yourself and let me know. Cool. I'm going to keep going at this size unless someone says something. I'm going to start a prize session. And prize session is similar to IRB. You probably have used IRB a little bit. And what it does is it opens up an interactive console where I can play with Ruby. And so by definition, a method is a group of related instructions that achieve some purpose. So for example, if I do this, and I hit enter, it's going to give me back hello world all in capital letters. What is happening here is that I'm calling the upcase method. What the upcase method does is that it creates a version of the string with all capital letters, right? And what we're doing here is that we're saying like, hey, for this upcase method, I want you to upcase everything on this object that I've called it on. And so this upcase method does this, really kind of cool functionality for us. And like the idea is that, what do we think? How do we do this if we didn't have that upcase method? Let's see who's making eye contact with the camera. Karen, how would you do this thing? If we didn't have an upcase method, what would you do if you needed to make like it all capitalized?
I don't know. I have no idea.
Okay, that's fine. Todd, what do you think? If we wanted to get all the things all things capitalized, but we didn't have an upcase method, like how do you think you might go about that?
I would just redo the string with all caps. That's what I would do.
That's legit. That's legit, right? Like, like in my mind, I'm thinking like, well, maybe I would do something where if I went through each letter, if it was capitalized, I'd leave it there. If it was lowercase, I'd figure out, do some logic to switch it out. And that seems like a lot to do, right? Like having to do that, just like, why don't we use upcase? I'm like, well, the idea is that the people who made Ruby made upcase so we wouldn't have to do this whole process again, right? One of the most important reasons why we use methods is that we can reuse code. Let's say the fine folks making cars in Detroit at our auto manufacturers. Do you think every single time they make a new car, they have to reinvent the wheel, like literally reinvent the wheel? Like, no, like we can reuse the ideas and things. If you, like, I think in cars, like with along the same brand of car, you can see like maybe like some parts are reused, like the air conditioning cold knob, right? Does it really hurt anyone if they use the same knob across various models? No, and this is kind of the same idea. We don't have to design a new knob; we have it already built for us. Every single time we have a situation where we need to capitalize every single letter in a string, we don't need to write code. Like, hey, this is a common enough thing where the people who made Ruby has given us this method that does this thing for us. And so when we write our code, when we're solving a specific problem, there are situations where we may need to reuse some of our code, and our tool to doing that is our methods, right? And so the second key point I want to talk about here is that methods run on objects. In this example, we are running the upcase method on hello world, which is a string object. One way to think about this is that methods are messages to an object. The equivalent of this is saying like, hey, string, and in this case, the string is hello world. I want you to give me an upcased version of yourself. And we see that its answer to that message is like a message back saying, hello world, all in capital letters. Right. So the two things we want you to remember from this little diatribe on methods. One, we use methods so we can reuse our code. We don't have to write like a bit of code over and over and over again. Two, methods run on objects. Any questions about those two things or anything about methods so far? I see a head shake from Kate, so that's a no. Anyone always feel free to ask questions, and to, if questions you feel are off topic, feel free to put them in your code help channel, and we will address all of them after the fact if you don't feel it's necessarily pertinent. I do also kind of want to reiterate how important it is that you do ask questions, because if you have a question you don't want to ask, I bet you at least 3 other people in this class have that same question and also don't want to ask. So I would rather you ask a question and I backtrack a little bit rather than move on and have potentially leave a couple people out of the loop. So we just talked about methods, and now we are moving to kind of like the second half, which is called something we call a return value. First thing about return values is that every method has exactly one return value. A return value can be any type. It can be the number 4, the string hello world. In this case here, hello world all in caps. It could be a Boolean, it could be true or false. It could be an array, which is a collection of items. It could be nil, which is essentially nothing. And so again here, we are running the uppercase method on the string hello world, and its return value here is another string, hello world all in capitalization, all capitalized. We can tell that this is a return value because in pry, we have the equal sign and the greater than sign. This little bit here, that's what lets us know that it is a return value. And so our next kind of, as we get more complicated, we have methods and return values, but sometimes we need to send our methods information, and we use that. We use a tool called arguments. To do so. We use arguments to input information from outside and put that into a method. When you define a method, they are known as parameters. A parameter is in general like a generic term for what gets sent in. An argument is a specific thing that gets put in. So here, what I'm going to do here is that I'm going to type in hello world, that string, and I'm going to call a different method on it. I'm going to call include question mark, and I'm going to type hello afterwards. And when I return this, when I hit return, it returns me true. Now, what is happening here is that I'm calling the include method on the string hello world, and I'm passing it the argument hello. One of the great things about Ruby is that Ruby is meant to read as closely to English as possible. And so let's say you have never seen this include method before, we can kind of see that because it returns true, it's essentially asking me, hey, is this string hello? Can I find it inside hello world? And because it returns true, we can say like, yes, it does, and therefore it returns true. So in this example here, we're hitting the 3 things that we've kind of talked about, right? We have this method called include. We are sending an argument hello to include, and we're running it upon the hello world string object. And then it gives us a return value of true, because hello world is going to, the include method will return either true or false. So if I can do the same thing, instead of hello, I can type in puppies, right? And knowing what we now know about include, what do we think is going to get returned? What is the return value going to be here? Just anyone pop up and answer.
False.
False. And it is false. And it's got to be false because, unfortunately, in this situation, there are no puppies in hello world. For the record, there should be puppies everywhere because that would be amazing. But in this situation with hello world, there are no puppies. One thing I want to note is that parentheses are optional in Ruby. This is functionally the same thing. I'm also not a great typer in class because I can feel all 35 of your eyes, well, actually 70 eyes on me, and that makes me want to type fast, and when I want to type fast, that's when I screw up. But this is the same thing that happens. And I keep telling myself, hey, you won't screw up typing, you just go slower, but I feel that if I type slowly, you'll judge me. But again, we have here in the parentheses, and it is essentially the same thing. I would say that in general, use parentheses. I feel that it is always better to be more explicit than implicit. I think that having those parentheses, what it does for me is that it really kind of focuses my vision and gives me like these borders of where things are. So automatically I know that anything inside these parentheses are going to be the argument. It just helps me give, when I code, I think it's very, I'm a little more visual than I am normally, and it helps me kind of separate this information out. Cool. And so we have this method. It takes one argument. We can also use some methods don't take any arguments. For example, upcase. We saw that upcase in the way we use it we did not send any arguments to it. Some methods also take multiple arguments. So let's do this. We got our good friend hello world, and we're gonna do gsub, oops, world Turing, and it returns me hello Turing. So just with these contextual clues, what do we think that gsub does? Let's get an answer from Greg.
So it looks like the so the first argument you pass in it will find that word in the original string if it's there. If it's not there, I would assume it would return nil or something like that, and then it will replace that with the second argument passed in.
Yep, that's exactly what gsub does, and essentially sub means substitute, right? That's like the kind of English kind of equivalent to it. And we see here that this is a method that takes two arguments. And again, to kind of prove the point that the parens are optional, we do that and the same thing happens. Questions about arguments, parameters at this point?
So yeah, Mike, if I can, just for understanding, the difference between an argument and a parameter is that a parameter is a variable and an argument has been defined.
I would say that the parameter is like a general thing, like these are its parameters. Like when we, I think it'll be clearer when we define our own methods. In general, like a parameter is, oh, this thing takes two parameters. But an argument is a specific thing. For example, I would say the gsub takes two parameters, but the arguments it takes here are world and Turing. To be honest with you, I often conflate the two terms and I use the words interchangeably because people, when you use them, like people just kind of get what you're talking about. So unfortunately, I do conflate the terms often. I probably shouldn't, but I just do because no one ever really corrects me on it. So I don't think that anyone will correct you on it because by using the words, you're going to convey what you mean and they'll get, like, the context clues will help a lot in kind of what you're talking about.
All right, thank you.
Yep. Josh, I saw a hand up. No takebacks.
Yeah, sure. Well, I was thinking maybe just to help think with that, the parameter is like the placeholder.
Yeah.
Okay.
That's a good term for it. Parameters is a placeholder, arguments are the specific things. That's a great word for that. Cool. So let's move on to like variables. And so what variables are keywords that we create that will either hold or point to return values that we want to maintain and reuse. For those of you that have taken like algebra, you'll be familiar with them. The idea is that variables I view them as kind of a shorthand to represent other things, right? So, like, let's say, for example, I've been doing this a lot, haven't I? Right? How many times have I typed that in so far? Like 7 times, which is, you know, like, that's a lot. And the idea is that, like, hey, we invented computers to make our lives easier. And so variables are one of these tools to let us do that. So why don't we do this? Let's say we have this hello world. And what I'm going to do is I'm going to make a variable called greeting. I'm going to set it to hello world.downcase. Knowing what upcase does, I'm going to surmise and kind of determine that, like, hey, downcase is going to do the same thing, except it'll make them all lowercase letters. And I see here that it returns me hello world. And what happens is that I've taken the return value of hello world.downCase and stored that into the variable greeting. So instead of having to type in hello world.downCase, I could do greeting, and that's hello world. And what we can do is that instead of calling hello world.downCase over and over again, we assign the return value to this variable, and we can use this later on. And we can use this something like this. We can use this technique called string interpolation, where we can do, this is our greeting. And use the octothorpe and the squiggly brace. And this will create a string with, this is our greeting hello world. Essentially, with that octothorpe and the squiggly braces, it just kind of takes the whatever is inside there, the variable that, and then convert that into a string. And so we've now converted into a string. Our greeting is our greeting hello world. So variables are this container or a pointer that we use in order to make it easier for us to reference specific things. And just because, and the idea is that we set it, but we can also change it. Let's say that with my hello world, I'm thinking too small. I want to think bigger than hello world. We can think better. We can do it. Greeting equals hello universe. Right? And now when we refer to greeting, we see hello universe. What do we think happened to hello world? Hello world has poofed off into nothingness. It is gone. When we have something and we set to a variable and we then decide to change that variable to something else, that is gone forever. We cannot use this variable to kind of reference it again. So that is something that's going to be kind of important to remember. Questions about variables? Awesome. It is 1:25. Let's take a Pomodoro break. Let's be back at 1:31.
Thank you, 31.
And so let me make this a little bigger. Can you all see my editor okay? Is that a large, good enough size? All right, so take about a minute here and think to yourself, what happens when I type in Ruby methods.rb? When I hit enter, what am I gonna see on the screen? So let's take 2 minutes to ponder this. Let's take 1 minute. You don't need that much time to ponder. All right. Kate, tell me what happens when I hit enter?
Nothing.
Nothing. Why nothing?
Because you've defined the class, you've defined the method, but you didn't actually call the method. So it's just processes what you've put in here, which is great, but you never actually called print welcome. So the puts is never going to happen.
Bingo, exactly. So we didn't see the welcome to calculator print on the screen because the class keyword here and the def keyword here, they define, important word, define the class and the method, but the code does not call a method. Like that's a very important distinction to make. We define the class, we define the method, but we do not call a method. So to make this run, what we need to do is that we need to first create an object, and then we call the method on it, right? Because methods have to run on objects. So the first thing we're going to do is we are going to create an object. Calculator equals calculator.new. And then we are going to run our method on it. Calculator.print welcome. And when I go down here, I run that, you see that it is running that method. We've defined it. Now we've added the code that it takes to go ahead and run it. So our next step is that we are going to show you how we're going to make this the best calculator ever. Right now, this is a very good calculator. It is about as effective as a potato. But remember that French fries were once uncooked potatoes too, and we're going to make this a little better. We are going to, and that's what I say about you. You feel like I don't know anything about programming. Hey, remember, French fries were once uncooked potatoes. You can be a French fry. Let's make a method called add. And right now, we're not gonna put anything in there yet. And so we're just kind of building this framework. Like we're kind of like thinking like, how do I want a calculator to work? Well, I would like a calculator that adds things, adds two things. You know, I think you need two things to add things. You can't do just one. And so we are going to have to give this some numbers to add together as an input. So what we're going to do is that we're going to define them. Num1, num2. And so what we're going to do here is that we're going to take away that welcome. We don't need to welcome anymore. We're using the calculator. We do calculator. Did I spell that right? I hope I spelled that right. And I'm going to run it. And it's going to be great. We're going to add some things together. It's going to be, we're reinventing math. Oh, and we get this error message. And it's not happy. It says argument error, wrong number of arguments, given 0, expected 2. And like that's saying that because we are trying to run the add method here. We're not sending in any arguments, but this add method as we've defined it is expecting to receive 2 arguments. So we kind of have to give it the arguments, right? So what we're going to do, we're going to add 1 and 3. Right, so we are just going to pass the thing, and it's going to be awesome, and we're going to run it. And all our problems will be solved. I don't know what 1 plus 3 is. That's why I've written this program. And we see that, hey, nothing happened. Well, the reason why nothing happened is because I'm calling this method, yes. I'm passing in parameters, and these parameters are the arguments 1 and 3. But I'm not actually doing anything with the method, right? It runs it, and nothing happens because there's nothing actually going on inside. So for now, we can do things like to show that whatever goes in takes this becomes the variable that holds it. We're going to do puts num1, puts num2 to show you that num1 will be 1 and num2 will be 3. We see it's 1 and 3. When we pass arguments to a method in this fashion, the arguments here, like num1 will take the value, will contain whatever this is in the first slot, and num2 will take whatever's in the second slot, and so forth, as however many you have. A good way to think of this is an argument here, like this num1, num2, are variables that are created right at the start. And we have now are able to use that variable anywhere inside that method. So have we built a good calculator yet? Like, no. It's like saying like, yeah, I want you to add 1 and 3 together, and the calculation's like, yeah, 1 and 3. There's your answer. I'm like, no, that's not what we wanted. We know we gave you the 1 and 3. We want them put together, not for you to tell us that we need to put this together. So our method needs to return the sum. And so what we can do, return value in a method's return value is one of 2 things. It is defined explicitly using the return keyword, or it is the last line of code run. So I'll show you the 2 ways that we can do this. Using the explicit return, we could do sum equals, because that's what we're doing, to taking the sum, is num1 plus num2. And then we can return the sum, like so. It's like saying like, hey, I've got num1 coming in, that's 1, num2 coming in, that's 3. I'm going to add them together. I'm going to store that in the variable sum, and then my next step is that I'm going to return that value. And when I run this code here, I get nothing. And the reason I'm getting nothing is like it returns it, but I'm not doing anything with it. So what I can do here is going to put a puts there, and I get that 4 that I've been looking for. Right. Without the puts, we just essentially told us like, yeah, go ahead and add those numbers. I don't really want to know what happens, like, but that defeats the whole point of calculator. Like, I made this so I want you to tell it to me. So what I'm going to do is I'm going to take the return value of calculator add 1, 3, which is going to be that 4, and I'm going to put it out to the screen. Very important to know that the idea that there is a distinct difference between returning a value and printing it to the screen. These are completely two different things. When we think of it like a computer is not always going to print something to the screen. And that's why those operations are discrete. And to show you what it looks like without the explicit return, we can simply do this. When we're not using an explicit return with the keyword return, the last line of a method, the return value of that is what gets returned. So here, the return value here is going to be 4. And to show you it does exactly the same thing, I'm going to print, I'm going to just run the program again, and I get that 4. Questions so far? Taylor.
So is it, I guess, best practice to use the implicit return or the explicit return keyword?
I would generally use, I guess it would be implicit. The last line, the whatever it is, I think that is generally what I would call idiomatic Ruby. The standard in the industry is that like you generally don't do the explicit return. It is, and everyone understands that like the last line is what gets returned. So we don't explicitly return unless we have to for a complex reason that you may or may not encounter in the future.
Okay, thank you.
Mm-hmm. Other questions at this point? George?
Yeah, thanks. So if you're in a method that has other things that are happening that are not the implicit return,
yeah,
what are those things called? Like, say you wanted to do something else in front, yeah, like online.
Yeah. Let's do that. 5 plus 7, 23 times 4. Math. Oh, that's the letter. That was wrong there. Yeah. We do that and we run it. We're still getting the 4. It still does this math. It's just that like it doesn't matter because it's not what it returned. Like any code that happens in above is going to run regardless, but like the only thing that gets returned is the last statement. And the reason why this happens is that like you may need to do other things before you can get to that answer. There may be like your method may do a series of discrete steps that may need to happen before you can come to an answer. Right. Jake.
I think question. Oh, sorry. Just to build on George's question, is there a term for those sort of intermediate returns, Mike, or is it they just don't have a word?
They aren't returns. They're just other steps.
Yeah.
I'm not familiar with a word for that. There may be a technical term for it, but like I've never had to refer to it specifically by any term.
Okay. Nice.
Jake?
So yeah, in that exact case, though, those top 2 lines, they're not doing anything basically. Usually they will encode.
They are running. Like with the computer is adding 5 plus 7 and is multiplying 23 by whatever. It's just that we're not storing that anywhere. We're not doing anything with it. Like I guess it's like one of those like things like, well, if you didn't see like a tree fall in the woods, did it really fall? Like it does. It's just that for our purposes, from our view, like we didn't see anything happen.
Okay.
So it's there. Right. Joshua?
If you were to do an explicit return on, say, one of the 5 plus 7, so if you did return 5 plus 7.
Yeah, let's do that. Let's do that. 12. Good question.
Thank you.
It returns it, and when it returns it, it's like, okay, I'm done.
So
yeah,
does
return
that,
is a way to kind of short circuits it. It's like,
okay,
I'm done.
so then I guess there would be some examples where you would have more than one explicit return within.
You'd have to do it within like a conditional, and we'll talk about
Right.
that later.
Okay, cool. Thanks.
Cool. Cheryl.
Yeah, is there a reason that you would put the puts where you put it instead of in the actual method itself?
Yes, that's a good question. The idea here is that we want to build our code in a way that's flexible, and so having the puts at the outside level means that like, hey, I want to grab this value, I want to print it out to the screen. What this does is it puts the I get to decide what I want to do with this information out here as opposed to in here. And so now if I have another method or another bit of code that needs to add something, I can now use this method instead of like, if it were puts in here, I would not be able to use that as a thing as it prints out to the screen. Like that's not the return value I want.
Makes sense. Thank you.
Cool. All right. So next up we want to talk about is we can also talk about method lookup, right? And the idea is that like we want to talk about where we can find methods. Let's say you are looking at some random code from anywhere and you see this. Where do you think I would look to find the does a thing method? Sydney, where do you think I would look?
I was answering it and I was like, it's gonna see my mouth moving. So above in your code, and the block of code above.
But what if it isn't in the block of code? Where would I look for? Where do I expect this does a thing method to be defined?
If it's not already built in, you mean?
Mm-hmm. Because the thing is that as we grow, right? The only thing I want to talk about here is like as we grow, like we're not going to have all our code in one file. Can you imagine how terrible that would be? Like if you were to work on like eBay site and everything was just in one file. That sounds kind of terrible, doesn't it?
It does.
Right. So usually our standard here is that if we're building a calculator class, I would make this calculator.rb. So knowing that, where would my does a thing method live in? What class would that live in?
The thing class.
Thing class. And knowing that, where do I find my thing method, my thing class?
I would have to create a new file and define that class.
Right. But let's say you already saw this, right?
Okay.
And so if you already saw a thing class being referenced somewhere, what file do you think that would be found in?
I may be overthinking it. So just so I'm clear, you're saying that, I just want to make sure. So we know that thing is the class. It's not referenced in this file.
Yeah, because we're in calculator.rb.
Because you're already.
Mm-hmm. Where do you think you could find the thing class? I'm sorry?
I guess, but for me, I would have another file that had the thing class defined.
100%. That's exactly it.
Okay, I was overthinking it.
It's fine. It's fine. It's fine. Like I will ask simple questions. Like I'm not the kind of person to ask complicated questions. So like, yeah. So the idea is that we want to name our files to be the same thing as the classes they inhabit. And so we do this because like, hey, I see you referencing this thing class. Like, how silly would it be if I were to make a dog class, but it's stored in the file cat.rb? Like, who no, that's one, it is funny, yes. But two, like, as a new engineer onto a project, you're gonna be like, where, I can't find the dog file. Where's the dog file? And then the engineer tells you it's cat. Like, why would anyone put it in cat? Like, that makes no sense. And this idea is that we do things in Ruby in a certain way so that it removes the kind of thought later on. So that whenever we have a thing class, it's always going to be defined in a thing.rb file and so forth. Cool. Okay, I see some hands. Give me a second to find out where my hands window is. Garrett?
Yeah, so so far, like I haven't personally dealt with, I guess, so far using like all the coding that I've done and practiced with, it's all kind of been in the same file, pretty much. And so I'm just kind of curious, like how do you work with like different files? Like, how do I call like the calculator.rb if that's in another file? Like, how do I call it and use that file in?
You would use
file, link to them all.
You'd use require and require relative, which you've seen a little bit already in your tests. And like if you've worked on Ruby exercises, you've seen that. And that's how it what require does is simply just kind of loads that in. That's how you reference other files from within a file.
Gotcha.
Okay. Joshua.
Is it also convention when naming variables to use the class name within the variable name?
Generally, yeah. Sometimes for convenience, you would name it something different. But generally it is. Like, I'll give you kind of like an example. Let's say that I had to instantiate, let's say I was working with users and I wanted to instantiate a couple copies of user. And let's say the users have names. I might name the first one Andrew if that person's Andrew. The second one I might name Alice if that user is Alice. You want to use your variable should be very descriptive and like kind of communicate what it is. So when I see Andrew, I'm like, oh, this is Andrew's user object. And I see Alice, I'm like, oh, that's Alice's user object. So if I'm just working with the one, I will most often just use the name of it. But if I'm working with multiple wings, I'm thinking of how do I differentiate in things in a way that is clear and makes as much sense as possible. Cool. Jesse?
Are there cases in which you would define 2 or more classes in one file?
Yes. You shouldn't. Sometimes I get a little lazy if I'm trying to do something real quick and I'll do it. But when the first chance I get, I'll move it to another file. You will see.
So in other words, each class should have its own file?
Yes, yes.
Okay.
You will see me occasionally define multiple classes in one file as I'm teaching, so you could see everything more easily. It's like it's all right there for you. Like as kind of like a teaching instructional thing, I'll do that sometimes. But I will, if I'm doing something for what I call for realsies, I will put it in a separate file.
Okay, thanks.
Cool. So another thing we can do with methods, let's go back to our calculator, is that methods can actually call other methods. And so to kind of talk about what Cheryl said, like, why do I print things out here? I'm like, well, what if I don't want to deal with it out here? What if I want to like have my calculator do that for me? Like, doesn't that belong to a calculator? And what we can do is that I can go in here. Let me just clean this up a little bit, get rid of the stuff we've been doing. Def print sum, first number, second number. Ooh. And we do, and how we can do is that like, hey, this feels, and the idea is that this method I want to actually print out to the screen. Am I going to do sum equals first number plus second number, and we're going to do a puts the sum of first number and second number is sum. I can do this, right? But what do we think is not great about this? It's a little repetitive, isn't it? Like this here, isn't this? Essentially, I'm adding two things together. And so what I can do is that I can reuse that. We could do sum equals add first number, second number. And now I'm leveraging this code I've already written to provide me the answer I want here. And so I'm going to go down here. I'm going to do print sum. And we're going to add 1 and 2 together, right? That'll be 3. And when I run this, oops, I can change the file name. I see the sum of 1 and 2 is 3. I'm using this, in this method, I'm reusing a bit of code I've already written. And this is what we talk about, like, this is the power of reusing our code in order to rewrite, like, in order to, like, not repeat myself, right? I'm not reinventing the wheel. Like, and yes, this is like a really, really kind of basic example. I'm just adding two numbers together. But let's think about, like, what if we scale up complexity? What if instead of this, I'm doing some really, really hard math? What if I'm doing math I don't even know the words for? Like the stuff with the Greek symbols that like no one wants to deal with that. And so now we can reuse this code. It's like, hey, I only need to figure it out to do that once. I don't need to reuse this code. And on top of that, when we think about, like, a reason, and this goes back to this concept called DRY, which stands for don't repeat yourself. If we start doing the calculation to add every single place where we're adding, what if there was, like, this new math where we've changed how we add? Like, you'd have to go hunt through your code for every single place that you've added and change it to a new way. If you're using one method and all of your other methods are relying on this one method, you need to make that change in one place. And this is like the power of abstraction. We use these methods and these classes to build out these higher level abstractions. And the idea here, the whole idea behind abstraction, is that we are exposing less complex functionality and we are hiding more complex stuff. The everyday example I like to use is a car. Like, I would say most of you are not able to disassemble a standard internal combustion engine. Like, for me personally, I understand that dinosaurs make oil and oil gets turned into gas and you put that in your car and it makes these little explosions that turn the cylinders and the thing turns. And as at a high level, I understand that. But as for a driver, you need to know that right pedal means go, left pedal means stop. I just had to do a mental check, like, that is the right pedals, right? Because, like, it's to the point where you don't even think, you just know the right pedal goes. You just step. You don't even think, like, oh, I have to use my right foot. You just know, like this is what abstraction is. You don't need to know the inner workings of a car, like the linkages, the transmission, like how the steering works. You just know you turn this way, your car goes that way. And this is the advantage. Like, did any of you, I think like a number of you probably have driven an electric car. And the idea is that if you drove a gas car and then drove an electric car, did you have to learn a new thing? Like, you didn't. Wheel still works the same. Left pedal still means go. Right pedal still means go. I should not be allowed in your car. Left pedal makes it stop. And this is how abstraction works in code, right? Like, let's say there was some kind of new technique to add things. You don't need to know that. You need to know that the add method takes 2 arguments and it will add them up. You don't care how that happens. Like, someone had to figure it out once, but, like, you do it the one time, and all you care back is that when you get the return value back, you get the added number. It's kind of like hot dogs. Animals go in one side, hot dogs come out the other. What happens in that sausage factory, we don't ask about. Will,
Yeah. This is sorry from a little while ago, but when you're talking about the unique file class that we've got, what do you call the file that basically runs all the classes? So like those, lines, was it 18 you have in your file there? Like, is there?
We'd call it like we refer to it as a runner file.
Okay.
Or the runner code. I would call it that. Yeah. Mm-hmm. We'll go into a little bit of that a little later on.
Thanks.
Curtis?
I'm assuming that this wouldn't be like really good code if you're trying to do it like this, but just for like understanding's sake, if you have a bunch of methods in a class and some of them are calling on each other, if you define a method that's calling on a method that like has not yet been defined in like the lines of code, will Ruby throw an error, or is it going to read through the whole class and say like it's defined later? Put it back here.
I see what you're saying. Let's do this. Let's do some method, right? We'll just show you right here. It scans it and it's like, don't know what this is.
But like if it's defined after that?
Oh, I see what you're saying. Like, yeah, let's just do it. It reads it in. Because the idea here is that when we run this, it's going to take all this and digest it. Nothing happened. It kind of holds it in place, and then here's where things actually get run.
Okay, cool. Thank you.
Right. Yep. Sydney?
So I'm a little confused just why we would call the same arguments for two different, like if we're already saying that pull arguments number 1 and number 2 and then add them together. And then in my next one, I'm saying, okay, now that you've done that prior, put the sum is equal to what has already happened above.
Yeah.
I have to read arguments.
Yeah. So what's happening here is that like when we define a class like here, it doesn't run. Right. So it just like when we run this file, it's like, okay, I got a class. I'm going to remember everything that happens here. I'm going to store that like in my memory, right? I'm going to remember that, hey, I have this class and I'm going to keep it here in my head. It only when we get to down here do things start happening. So when we kind of go through, it's like, okay, calculator is calculating. Okay, we're going to instantiate a new instance of calculator and we're going to store it inside this calculator variable. Okay, so we have this stored and we can refer to it as calculator. Only here are things actually getting run. So far, up to this point, nothing has been run yet. Here, what says like, I want you to run print sum on the calculator method, calculator object. I want to pass it 1 and 2. So we get to here to this print sum method here. We haven't done anything with this yet. This has not been referenced. This has not been called yet. It just kind of lives in this place that it just exists until we need it. And so 1 gets stored into first number, 2 gets stored into second number. And then here, when we call add and we send in first number, we send in 1 and 2 here, that's when this gets called.
Okay.
And not until then. So it feels a little redundant now, but like we gotta remember that like things don't exactly happen that in order that they're defined as you're going through code. Things only get run. I'm sorry?
Could you name your arguments the same as they were called in the other?
You can. Mm-hmm.
Okay.
You could. I just named them something different to show that these are separate things.
Okay.
Mm-hmm. Like for example, let's say I think to kind of expound on the point you're trying to get at here. What if I made this method called def shout? And if I were to run this right now, what do you think would happen?
Sorry, nothing, because you're not telling me to do anything.
Exactly. So the same idea happens here is that this does not get run until I do it explicitly, which I've done so here.
Okay.
This does not get run until I've done so explicitly, which I've done so here.
That makes sense. Okay, cool. Thank you.
No problem. All right, so let us take a break. We'll be back at 2:10.
Thank you.